Hello students, I hope you are well, good and fine. So we will continue our lecture on constructions. Okay, so let's begin with today's outline. The first and the main thing in our today's lecture is to construct a triangle with if a base is given, if angle is given, if two sides is given, and there might be some more or other conditions according to which we have to construct our triangles, and we will see through various examples of it. Okay, so let's see our first example or the case. To construct an equilateral triangle, when its one side is given. So first let's see what is an equilateral triangle. So equilateral triangle, equilateral triangle. Okay, so equilateral triangles are those triangles which have same side length. Okay, also their interior angles all are equal to be 60 degree. Okay, so it's look like this. So it is, suppose this is 5 centimeter, this is also 5, this is also 5, and the angle is 60 here, 60 here and 60 here. So equilateral triangle. I hope you understood the meaning of the equilateral triangle. So we have to construct an equilateral triangle when one side is given. So we are given with only single side. Let's jump to our main how we are going to construct. So let's see, if we have to draw an equilateral triangle of side 2.5. So how we will be begin. So so I know I have to make a triangle in a such a way that all these sides will be 2.5 centimeter in length. Okay, so how let's begin with a line segment of distance 2.5 centimeter. Okay, name it say B and C. So this line segment length is 2.5 centimeter. So we use ruler for this. Okay, first step. Okay, now we do the second step. So in first step, using ruler, draw a line segment of length 2.5 centimeter. Okay, so here is the BC line segment of 2.5 centimeter. And in second step, taking or taking compass, okay, taking compass and letting B as our center. So suppose this is our compass. Okay, so this is our compass, and taking B as a center. B is now our center, and other end of the compass placing it on C, and making an arc like this. Okay, and third step is to perform second step, but this time C is our center. Okay, I hope this is clear. So in first two steps we have things like this. So an arc, okay, an arc like this. And now in third step, the center is here, compass is like this, and other end of the compass is on B and making an arc. Okay, and both red and the blue arc will intersect at some point, and that point we name it as A. So the final picture or the final diagram will look like this. B, the line segment B and C, the arcs, the two arcs, the blue one and the red one, the two arcs, the blue one and the red one intersecting at point say A, and now we join at last we join A and B and A and C, and this will be our equilateral triangle. Okay, equilateral triangle. I hope the construction is clear to you. Because it is equilateral, because all of the side length is 2.5, 2.5 and 2.5 because of the constructions. At first we have took the center as B and taken the arc length as of 2.5 because one end is here and another end is here. So the total length of BC is 2.5 centimeter. Okay, I hope this is clear to you. Okay, so the construction, you can easily draw an equilateral triangle with any given side without facing any issue. Okay, just take one end of the compass at here and putting another end to here. Now shift the center to this one and now other end at here, and just the intersection point of the two arcs, then join that intersection point to both the ends of the line segment here, in this case B and C, and the final diagram will produce a triangle which will be your equilateral triangle. So in this case our final diagram is this, with the equilateral triangle with the 2.5 centimeter of side. Okay, I hope this is clear to you. Now let's move to next. Now see the case 2. In case 2, if a base of a triangle is given. So what do we mean by base? So base is the side of a triangle on which the triangle is standing. For example, let's say this is a triangle A, B and C. Okay, this is a triangle ABC. Here base is equal to AB. Okay, if this is a triangle, say PQR, so the base, in this case the base is PQ. So base is this on which the triangle is standing. Okay, I hope this is clear. So in case 2, we will be constructing a triangle with when one base angle is given. And what do we mean by base angle? So base angle is this, base angle is this, or base angle is this. So it depends. We have two base angle. Okay, so one is this one and another is this one. So we are given with one base angle, so it could be this one or this one. So we are given with two base angles. Okay, but here the case is to draw a triangle with if the information given us to is one base angle and the sum of other two sides are given to us. Okay, let's see how we are going to do that. So one base angle is given. So what the information we are given? So this angle, let's say this angle is given because this is one of the base angle. This angle is given and the sum of other two sides are also given to us. I hope this is clear to you. So how we are going to do that? So it is quite easy. Let's see. So let's draw a line segment of any length if you want. So let's say B and C, and one angle is given. So the rough diagram will look like this. Okay, I hope this is our starting information. Okay, so now let's directly see how the questions will frame. So for example, if base is 3 centimeter, okay, if base is given with 3 centimeter, the sum of other two sides given is 8 centimeter and one base angle is 60. So rough diagram, let me draw a rough diagram so you can have an idea that how our final diagram or the final construction will look like. Rough construction or the rough diagram. Okay, diagram. So base is 3 centimeter. Okay, base is of 3 centimeter. This is base, base. Okay, and the sum of other two sides. So let's say other two sides, sum is equals to 8 centimeter. I hope this is clear. And the one base angle, and say this is one of the base angle which is 60, which is of 60 degree. So the final diagram will look like this, with base of 3 centimeter, one base angle is of 60 degree, and the sum of this and this side, the red colored two sides, the sum will be 8 centimeter. So let's begin with this information. So base angle, let me draw a 3 centimeter of base, name it BC, 3 centimeter, and construct a 60 degree angle. You can use the previous knowledge how to construct an angle of 60 degree. Okay, or you can just use protractor. Okay, so you can just use protractor or just follow the previous steps in the previous lecture we have discussed. Okay, so I'm just directly writing the 60 degree. Okay, just assume I'm using a protractor here. Okay, so a 60 degree angle will look like this. I hope this is clear to you, a 60 degree angle. Okay, or let me provide you the how we constructed 60 degree angle. So as B and C is our base of a triangle or a line segment, so just use a compass and take B as our center and make an arc of length more than half of BC. Okay, so just taking an arc, suppose this is our arc. Okay, with the same radius, now shift our center to this point wherever this arc cut BC, and now taking this center, and with the arc length remains the same, and cut our arc again, like for example at this point. Now join this red point and the original point B to get our 60-degree angle. So this angle is 60-degree. I hope this is clear. Okay, so the intersection was like this. Okay, so 60-degree angle. Now what? So we have drawn a 60-degree angle, or the one base angle, and we have base of a triangle with a 3 centimeter. So now what we have to do? Now we have to construct two sides in a such way that the sum must be 8 centimeters. So the first step is this. The second step will look like, let me copy the diagram up above. So it is 60. Okay, I hope this is clear to you. And okay, now now use a ruler to measure 8 centimeter of length on this ray produced by B colored with red. Okay, so 8 centimeter, and mark that point, say D. Okay, so this point is D. Okay, so this point is D. We cut our B, say name this ray red ray with BP. So red ray is BP, red ray is our BP, and we cut our red ray of length 8 centimeter. Wherever it cuts, we name that point a D. For example, here that BD length is equals to 8. I hope this is clear. So BD length is 8. Now join B and C. So joining B and C will get this. And now what we will do is to draw a perpendicular bisector of CD. So perpendicular bisector meaning if I have A B line segment, and perpendicular bisector meaning that a line which cuts AB into two equal parts, say AO and OB, two equal parts with angle of 90 degree. So these two things must happen if we are using this perpendicular bisector term. So we are going to draw a perpendicular bisector of DC. I hope you remember what were the steps of this. I am just directly using here. I hope you can revisit my previous lecture for this. Okay, so let's draw a perpendicular bisector. Suppose this is my perpendicular bisector. Here it makes 90 degree, and this point name it as O. Okay, I hope this is clear to you. Now this point is O. Okay, now join this O and B. Okay, now join this O and B. Let's join it. Okay, now let's see suppose and this O intersect. If you see the green line or the ray intersect the red one, so name it point say Z. I hope the diagram is clear. Okay, now if you try to see an triangles, if you try to see two triangles, what triangle I am talking about? So triangle I am talking about is this one. this triangle, okay, this triangle, or let me here this triangle, the ZDO. Okay, so ZDO, one triangle is this, and another triangle I'm talking about is what? So another triangle I'm talking about is this. Okay, so if you see that DO is equal to OC, this length is equal to this length. I hope this is clear. Okay, now what? Now I can say easily that DO is equals to DC, and D, say DOZ, angle DOZ is equals to angle, what angle I am talking about? I am talking about this angle. So this is also 90 degree. I hope the steps are clear. I think the let me draw the diagram once again. This looks quite messy. Okay, or let me just use the diagram here. Okay, so I'm using diagram here and the terms also. So let me again process the steps for you with new names. Just what I did, just used BC line segment with 3 centimeter and make a 60 degree of angle, if you remember, with the red line. The 60 degree was here, and then what I did, I cut the 8 centimeters of length of this red ray. So this ray, what I named it, say P, so BP, red ray, and the 8 centimeter of length, say cut over here, is T point. So 8 centimeter of this. Okay, now what I did was just joined this D and C. Okay, I hope things are clear, as you can also see over here. Okay, but here I am doing one by one or step by step. Okay, now what, after joining, what I did the perpendicular bisector of DC. So perpendicular bisector of DC, cut this line into 2 equal parts with of angle 90 degree each. I hope this is clear to you. And this point of intersection is O, and this point of intersection, name it Z, but here we will be using A. Okay, so A. Okay, I hope now we join this. Okay, in previous I was joined B and O, so that was something else, but here for the sake of the construction or the question, we are going to join A and C. Okay, I hope the previous steps are not doing any problem to you. Okay, so joining A and C will give me 2 triangles. Now if you see, I have 2 triangles, so ADO and another triangle with AOC. I hope you can easily see. Okay, now in those 2 triangles I am talking about triangle AOD and triangle AOC. If you see, we know that OD is equals to OC. Yes, OD is equals to OC because of the perpendicular bisector. We draw a perpendicular bisector. Okay, so because of that, the O point of DC intersect the line segment DC into 2 equal parts, which is DO and OC. Okay, I hope this is clear. Now this angle, this angle is 90 degree because of the same reason, the perpendicular bisector, and both are equal to each other. So angle AOD, angle AOD is equals to angle AOC. Both are of 90 degree. Okay, and AO, this line segment, or this side of the from the both triangles are common, is common. Okay, so AO is common. AO is common. So the side, angle and side. So from this rule, side, angle, side, we can easily say that both of the triangles are congruent. And so if they are congruent, so does the corresponding part of the congruent triangles must be congruent. So here in this case, this side AD, this AD must be equals to this side AC, because of the corresponding part of the congruent triangles are congruent. We already knew that this side is equals to this side, and this side is common to both of the triangles, and the remaining side must be equals to the remaining side to the another triangle. So AD, so we showed AD is equals to AC, and we know that BA plus AD, which is the whole line segment BD, which is of the length 8 centimeter, and we know AD is equals to AC, so BA plus AC is equals to 8 centimeter. So if I draw this triangle alone, this triangle, okay, so let me draw here. So this triangle is here, BCA with the 60 degree angle, and I know this side AB, if you see this, AB plus AC is 8 centimeter, that is the sum of other two sides is 8 centimeter. The base, one of the base angle is 60 degree, and the base of the triangle is already we took 3 centimeters. So all the conditions are satisfying. I hope the construction is clear to you, and the proof as well as. Okay, so let's move to next. Okay, I hope this is clear. So this is the proof. I have already told you every bit part. Okay, so let's move to next. So now construct a right angle. So what do we mean by right angle? So right angle triangle. Okay, so right angle, first of all, right angle means the angle of 90 degree, and right angle triangle means a triangle which has one of its angle of 90 degree. So this type of triangle we call right angle triangles. Okay, I hope this is a good intuition to understand what is right angle triangle. Okay, so we want to construct a right angle triangle with 3.8 centimeter of its one side, and another the sum of other two sides, which is the remaining side, and the hypotenuse is 6 centimeter. I hope this construction you can easily do by performing the previous steps, because here one base angle is given, to equals to 90 degree, because if you see the rough diagram, always make a rough diagram so that you can have an idea of what we will be constructing. Okay, so our image will look like something this. So the 90-degree, this is our hypotenuse, this suppose it is the base. So take base as 3.8 centimeter. In the previous we took 3 centimeter of the base. Okay, so let me give you a comparison to the previous question and to this example. So in previous the base was of 3 centimeter, one base angle was of 60-degree, and the sum of other two sides is equals to the 8 centimeter. Here the same thing, if you say base is 3.8, the base angle is of 90-degree, and the sum of other two sides, so the sum we are talking about this side and the hypotenuse, sum of other side and the hypotenuse, so this is our other two sides apart from the base. Okay, so which is equals to 6 centimeter. I hope you can easily draw this. Okay, so this construction is quite easy to handle. So let me give you rough and fast steps to do that. So first we will be drawing 3.8 centimeter of base, and then an angle, 90-degree angle. Okay, so you can easily draw a 90-degree angle with having this BC. Take BC as our line segment of 3.8 centimeter and a ray originating from B marking an angle with BC of 90-degree, and say it is BP, so ray is BP. Okay, now what we needed, so the sum we needed is equals to the 6 centimeter. I think the sum is, yes, it is 6 centimeter. So take a ruler and mark a 6 centimeter of length on BP. So suppose the 6 centimeter cuts the ray at point D. Okay, so this is BP. Now BP is of length 6 centimeter. Okay, now join B. Okay, now joining B and C. So we joined B and C. Okay, now what we will do, we just perform the next step, which is to drawing a perpendicular bisector of DC. Suppose the perpendicular bisector is this, the point is O here, it is 90-degree, this side is equals to the side this, and this intersection point, name it as A. So this point is A. I hope it is clear. Let me draw a big diagram for you. So B, C, the 90-degree angle. Okay, this ray is our BP, and this intersection point D of 6 centimeter, we joined DC, and then we bisect perpendicularly, or we drew a perpendicular bisector of DC which cuts DC at O, making this 90-degree angle, and this side is equals to this side because of the perpendicular bisector meaning. Okay, and this, if you see the orange or this line cuts the red line at some point, name it as A. Now I hope this is clear to you. So now join A and C. In previous we already we did the same. So joining A and C, we will be seeing two triangles. One is this AOD, one triangle is triangle AOD, and another triangle is the triangle AOC. I hope you can easily see. Another triangle is AOC. Now in both of the triangle, we saw some observation. The DO is equals to OC because of the construction we already did, and the angle AOD is equals to the angle AOC because it is of 90 degree, and this AO line segment or the side of the triangles from the both triangles is common. AO is common side from both the triangles, and by side angle side we can say from side angle side rule we can say that both of these triangle AOD and AOC are congruent. So by CPCT, by congruent part of the corresponding part of congruent triangle are congruent. Let me write. So corresponding, okay, so the corresponding part of congruent triangle are congruent. Okay, so corresponding part of congruent triangles are congruent. I hope this is clear. So from this we can say that AD, we can easily say that AD will be equal in length to AC. I hope this is clear. So this implies AD equal to AC in length. If you see that BD is equal to AD plus AB. So if you see BD is this whole line segment of 6 centimeter. So this is equals to 6 centimeter, and it divided into two parts which is are not equal, or they could be, we don't know yet. And AB, from this we can easily see that BA or AB plus AD is equals to the 6 centimeter of length. Okay, and we know AD is equals to AC, so AC plus AB, okay, AC plus AB is 6 centimeter. So if you see the triangle ABC, the triangle here, the triangle, let me use yellow to outline ABC triangle. So this is our ABC triangle. So in ABC triangle, so triangle ABC, we know this is of 90 degree. We know the base is 3.8 centimeter, and the sum of other two sides, one is this perpendicular and the hypotenuse, which is AC. So B A, so BA or AB is here and AC is here, and the sum of the both two sides excluding the base is equals to 6, as it was given in our example. Okay, I hope the construction is clear to you. Okay, now let's move to next. Okay, I hope this all things are clear to you. Okay, so these are the steps which I did. So drawing the just the terms or the namings of the segments are different. Okay, the points. Okay, I drew the BC base, and here they are drawing AB base. Okay, so just no need to worry. So but the final result will be the same. Okay, so this is are required, or this, if you see this little ABC angle is right angle triangle with the same property. uh, in the questions we have. Okay, I hope this is clear to you. So now let's move to next case, the case where we have the perimeter of triangle is given and both base angles are also given. I hope this is clear. Let's see our example. So constructing, so first of all, drawing a rough diagram. Rough diagram is to draw an A, a B, and a C. Okay, now drawing A, B, and C, what we will do. So now the triangle ABC is looks like this, and name it ABC here, and we know AB plus BC plus CA, the perimeter. It is our perimeter. So perimeter. So perimeter means the total length of a boundary of any shape. Here the shape is triangle, so the boundary is this AB, BC and CA. So boundary is this. So this is our perimeter, which is given to us is 12 centimeters, and angle B, this angle B is of 45 degree and angle C is of 60 degree. I hope this is clear. The rough diagram how the our act or the construction will look like this. Okay, with this thing to be satisfied. Okay, so let's move on to the steps. So what we are given, so always start what we are given. So we know the perimeter, we know the two angles. So just draw the perimeter first of the base. Let's say drawing a line segment, PQ of 12 centimeter. Okay, because it is our base, sorry, the perimeter length. So we will manipulate in this in such way that we will get our condition satisfying. Now at P, construct a line PR. Okay, construct a line PR such that the angle RPO is 45. If it is saying just enough that using a compass, make P as our center and use steps from which we used to construct a 45 degree angle. Okay, so as P our center, using compass just drew a 45 degree of angle. So how we did it? So just the first we used to 60 degree angle and then bisect it, and then again bisecting it will get our 45 degree angle, or just use protractor. Okay, protractor. Okay, you can use a protractor or just the construction. Okay, so here we got our 45 degree angle and naming this, and this red line is R, say R. Okay, we have our red line. Okay, now this angle RPO, RPQ, I hope this is Q, I think. So RPQ is 12. Yes, it is 45. Sorry, the RPQ is 45. Now at Q, taking Q as center and drawing such line which makes a 60 degree angle at Q. So it is quite easy. Just Q as center, use protractor, and our 60 degree angle will look like something this. Okay, I hope this is clear. Just use protractor or the steps we did in the previous lecture to construct the 60-degree angle, which is quite easy to construct. So now what we will do, we will be doing the bisector of angles. What angles we are talking about? The angle RPQ, which is of equals to 45 degree, and the SQP. So this line, this green line is naming as S. Okay, so SQP, which meets at point A, and this if you see the intersection, the green and the red lines are intersecting, and we are naming it as A. Okay, I hope this is clear. Okay, now what? Sorry, I think this is not the point A which we are talking about. In the third step, we draw a bisector of angles. So we are talking about the bisector of angles. Okay, so we are talking about bisector of angles. So angles we are talking about of what? P, this angle, and this angle. So we bisect our angles. Okay, so let me draw another diagram here. So our triangle, so far we have drawn like this. So this is of 12, it is P, it is Q. This red line is was R, and this is is 45 degree. This was 60, the 60 degree. Okay, this is 45. Let me use red so that you can not confuse. Okay, so now we bisect this 45 degree angle. So bisecting this angle, so suppose we bisect this and bisecting this angle also, bisecting this angle, and this intersection point we call it as A. So this point is A. Okay, so after bisecting both of the angle, the intersection point we call, or we name it as A. I hope now it is clear. Okay, so we did our third step. So now to fourth step, drawing a perpendicular bisector of AP. Okay, which means PQ. Okay, now drawing a perpendicular bisector of AP. So now the perpendicular bisector of AP, let me once again draw the diagram. So our diagram was like this. So P, Q, okay, and this was our A. This is the half of the 45 degree, and this is also the half of the 60 degree, because the point A was the intersection of the intersection of the angle bisector of this angle and this angle. Okay, I hope this is clear. Now drawing a perpendicular bisector of AP. Now the perpendicular bisector of AP which meets PQ. So this bisector, which meaning naming it meeting at PQ at B. So this point we name at B, and this is 90 degree, and we know this length is equals to this length. So this point name it at Z. So PZ is equals to AZ or ZA, because it is a perpendicular bisector. Okay, now doing same with AQ, AQ, perpendicular bisector of AQ, perpendicular bisector which meets PQ. So again perpendicular which meets PQ. So this is also 90 degree. This length is equals to this. Name it as Y, and at here it meets at C. Okay, here it meets at C, and we know AY is equals to Y Q because it is a perpendicular bisector. Bisector meaning the line segment is separated into two equal parts, or divide, sorry, the divided, the precise or the accurate word is to divide. The perpendicular bisector divides the line segments into two equal parts. Okay. Now what? Now in the sixth steps, we now join A B. So we already joined A B and sorry, we are going to join A B and A C. So joining A B and A C. So now we join A B and A C. Now this triangle, this final triangle will be our required triangle with satisfying all the properties we have. Okay, I hope this is clear to you. Okay, the construction is quite simple. Okay, so I hope this is clear.